A lot of stuff going on today, my friends. We're going to take a look at these quadratic functions that we've been graphing yesterday and previous days. And we're going to find out things about the axis of symmetry or the coordinates of the vertex. Those are some things that you found before when you were given a graph. But now what if we're given an equation? How do we figure that out? And you might remember from the last unit we did about the roots of the function. So we're going to talk about that as well. So a lot of fun things today. So first of all, you see here a graph of y equals x squared plus 4x minus 1. So there's a line that cuts this parabola in half. On your paper, draw what that equation is. Yeah, you can't really draw an equation. You can draw a line, though. So I'm thinking that line is probably going to go something like that. It's going to cut it in half. So let's see. It looks like that's the equation. If these axes are 1 unit each, it looks like this is going to be the equation x equals -2. And you might remember that's our axis of symmetry, right? That's our line that cuts the graph in half. So here's how we find the axis of symmetry. Yeah, when you're given a graph, whoops, can't spell cuts. How about that? It's the graph that cuts the parabola in half. And it's usually an x equals some kind of a number, because our parabolas are either going to open up or open down. Now, when we're given an equation, though, yeah, we could go and graph it somehow and then figure out the line that cuts down the middle. But there's another way to do it, and it actually comes from the quadratic formula which you learned. The equation for the axis of symmetry is found by doing the -b over 2a part of the quadratic formula. You might remember there was like a plus or a minus. There was a big square root over 2a. Well, the -b over 2a is actually the axis of symmetry part. It helps you find the middle of the parabola. So make sure you get that formula down. That is awesome. Here we go. So show me what you know. What is the equation of the axis of symmetry for the graph that is pictured on your left? You draw that line down the middle. It looks like it intercepts the x-axis at 3. So the axis of symmetry is x equals 3. Now for the next one, we have an equation. So let's use that formula that we had. Remember, the equation for the axis of symmetry, AOS, axis of symmetry, is x equals -b over 2a. So in this case, my a value is 2. My b value is -8. I'm not worried about the c value here. So the equation for the axis of symmetry then is x equals -b over 2a. So if we simplify this a little bit, -8 is +8. 2 times 2 is 4. So the equation is x equals 2. And please note that the equation that we just worked with does not represent the graph above. There's two kind of different problems. Oh, that's what that blue line means? Yeah, it separates the two different problems. Cool. Well, this is really neat, because now we know the axis of symmetry is x equals 2. And let's think for a minute about this now. We know the axis of symmetry is the line x equals 2. This is the equation we just did before. So now if we know the axis of symmetry from before, which was x equals 2, let's think about how we would find its vertex. Because the vertex of the parabola is the turning point. Remember, the vertex of a parabola, if our parabola goes something like this, that's the vertex point right there. So if you notice, the axis of symmetry passes through the vertex. As a matter of fact, the axis of symmetry is the x value of the vertex. Should I write that down? Yeah, worth knowing. Worth knowing. So if we know the x value of the vertex, we're halfway done with our answer. Our answer, let's look ahead a little bit. We're going to put a little answer box here. It's going to be the point 2, comma, and we're going to put something in there. So let's figure out how to get what goes in there. We know our x value. Let's plug it in. So y equals 2 times 2 squared minus 8x plus 3. So you do the order of operations, right? So we're going to square 2 first and get 4. times 2. Ooh, I forgot to write a 2 in there, huh? So let's see now. We're going to get y equals 8 minus 16 plus 3. So our y value then is going to be negative 5. So my answer, the coordinates of my vertex, is at 2, negative 5. So in order to find the vertex, take the axis symmetry. Plug it in, plug it in. All right, so we hit axis symmetry. We're good with that. We hit vertex. We're good with that. Where do you go on a graph for the y value to equal 0? Well, think about it. The y equals 0, that's where you're on the x-axis. So now we're going to bring back something from last unit, the roots of an equation, or the zeros of it. The roots of the function is where the graph crosses the x-axis. That's why they're kind of called roots. You can kind of think of below the x-axis as below ground. The x-axis is the ground. And above the x-axis is like our living space. So the roots are where it hits the x-axis. So if we want to find the roots of the graph, check it out over here on this graph to the left. It looks like I have an x value of negative 1, and I have an x value of positive 2. Those are my roots, negative 1 and positive 2. Take a look at the middle one. It looks like it's x equals 1. Now, I know you were saying, well, aren't there two answers with quadratic equations? There are. You're right. So do you want to say that there's another one like x equals 1? There's two answers, x equals 1 and x equals 1. They're the same root. Pretty cool. Yeah, but the last one doesn't cross the x-axis. You're right. So for this one, we say that there are no real solutions. If the graph doesn't cross the x-axis, there are no real solutions. Nothing we can do about it. Cool, so the roots are where the graph crosses the x-axis. Love it. So let's do this for a moment. Let's take a look for the axis of symmetry, the vertex, and the roots of each graph below. And then tell me if it's a maximum or a minimum too. Do the one on the left first. Okay, so we got to find the axis of symmetry first. X equals, let's see, that line that's going to separate, that's going to put it right down the middle. Bam, it looks like that. X equals 1. Oh yeah, remember something. It's the axis of symmetry is an equation. Don't just write 1. Tell me it's x equals 1. Don't write AOS 1. Write x equals 1. Make sure you do those things. And let's see what our vertex is. So we know the vertex then is going to be the point 1 comma something. It looks like I go up 1, 2, 3, 4. What do you think about right about there? About 4.5 maybe? I'll take 4.5. I'm good with that. How about the roots of it? So the roots of our graph are the x's where it crosses the x-axis. So it looks like x equals negative 2. And x equals 1, 2, 3, 4, 4. You can even write the roots if you want. Remember writing them this way? Wait a minute. So we can actually solve all those quadratic equations by graphing them and finding where they cross the x-axis? Yes, you can. We'll do that in class. Oh, I love this stuff. Me too. How'd you do on the next one? Axis of symmetry. How about being at x equals 3 this time? How about our vertex being at 3 comma that point right there? Looks like it's at negative 8 for a y value. And let's keep rolling. How about the zeros or the roots? Maybe I'll be cool and I'll write them as a squiggly bracket. How about at 1 and 5? And I know what you're saying. You forgot about the maximum and minimums. You're right, I did. Good catch. So let's go back to the left for a minute. This vertex here that I'm drawing in green, is its y value, is 4.5 the largest y value or the smallest? Yeah, that's the largest. So this graph has a maximum because the parabola opens downward. And the one on the left is a minimum because the parabola opens upward. So negative 8 is the smallest y value. So we can do all that from a graph. Oh, you're wonderful. So can we do it all from an equation like this? Give it a shot on your own. So for your axis of symmetry, remember that's going to be that negative b over 2a. So we have negative b is 8. Careful here. Did you see that the a value is negative 1? Remember, a is the number in front of the x. So it's really like a negative 1x squared there. So a equals negative 1. Careful, careful. So let's see, that's going to give me x equals negative 8 over negative 2. So the axis of symmetry is x equals 4. Did you then plug 4 in? Check it out. So I'll use my function notation because I got a function here. So the function's value at 4, I'm going to plug x equals 4 into my equation. And again, notice those order of operations there. So the order of operations tell me that I got to square 4 first and then make it negative. Negative 16 plus 32 is a positive 16. Minus 3 is 13. So how about that vertex being at 4, 13? I was going to write negative. I want it to be positive. So now you got a formula to help you find the axis of symmetry. You can use that to find the vertex. And the roots are where it crosses the x-axis. I tried to make a song out of that and it didn't work.